All right, so lesson 2.07 and 2.09 is on circumference. If you've ever had an empty toilet paper roll or empty paper towel roll and you hold it up and you look at it straight on, that's a circumference. It is the distance around a circle. Just like perimeter is the distance around a rectangle or a square, circumference is the perimeter of a circle. So literally, circumference is what makes up that circle. It's that distance around. And there is a special relationship between the circumference and the diameter. Okay? Remember, the diameter is that chord that goes through the center of the circle. So let's say our center is at center A. That chord that goes through that center is called the diameter. And then that piece of the diameter that is from the center to the edge is called our radius. Okay, so we have the radius, which is, hint, hint, half of the diameter. And then we also have that diameter. There's a special relationship there that helps us come up with this awesome number that's found everywhere. Like, math is real world, and this number is that ratio, and that number is pi, which is approximately 3.14. Now, pi is an irrational number that is which means it is a decimal that continues to go on. Like, they've even had competitions to see who can learn the most digits of pi. I was never in that competition, but it is a thing. Okay, so we're going to be talking about the circumference and how the diameter and radius all go together. Please watch that Khan Academy video. It's going to help. Okay, all right, so basic formula is this. Circumference is equal to 2 pi r, or circumference is equal to the diameter times pi. Because remember, 2 times the radius is the diameter. So both of these formulas will help calculate the circumference, which is, again, the distance around the circle. It's the perimeter of a circle. Both will calculate it. So let's look at a question. I forget that they actually have this circle tool. I really should be using it. All right, let's actually make it a little more circular instead of ovally. We'll draw our diameter, and then let's give that a value of 16 inches. Okay, and the question is this: what is the exact, pay attention to the wording, exact value of the circumference of the circle? Okay, because they use the word exact, you actually need to use pi. Okay, we need to use pi because pi, that symbol right here, is not a rounded number. This is a rounded number. So if they want the approximate, we would actually sub in 3.414 for pi. But if they want the exact, then we would actually use the exact. So since we already know our diameter is 16 and circumference is equal to the diameter times pi, the circumference of this is 16 pi inches. So again, don't overthink this. Don't overthink it. That is all you would need to do to calculate the circumference. If they want the approximate value, they are going to tell you to substitute 3.14 in for pi. So the circumference would be 16 times 3.14, which is why I have my calculator up. Make sure you guys have this calculator. 16, you can even plug in the real pi right there. But do not, if they give you 3.14, you got to use that one. Okay? It'll round weird if you don't use 3.14. In fact, I might show you here in just a second. So C is approximately 50.24 inches. Okay, so this would be the approximate answer, and then this would be our exact answer. All right, let's say they give us a circle. Let's do pink. There's a circle, and then they give us a radius of let's do 6 centimeters. Has a radius of 6 centimeters. And they want to know the exact circumference of a circle that has a radius of 6 centimeters. But remember, circumference is 2 pi r or 2r pi. However, it's always been written in my head 2 pi r. I'm not really sure. But it's just 2 times pi times the radius. But the cool thing with multiplication is it's a commutative property, which means we can reorder this to say 2 times 6 times pi, or 12 pi centimeters. So the circumference would be 12 pi centimeters. Just double your radius, you'll be fine. All right, let's see what else we got. I think, honestly, that's gonna be it. Oh, just kidding. So that's the basis for understanding circumference of this type of figure. Here's what we're going to run into. They're going to give you composite figures that are partial circles. In fact, we were just looking at a house that had a window that looked like this. Okay, it's called a quarter window, right? It's a quarter window. In this situation, this is basically a quarter of a circle. Unfortunately, the perimeter of this figure is not 1/4 the circumference because you have to consider these pieces here. Let's do this. Let me adjust this just a little bit because it is not quite to scale. So let me make this a little bit longer because these are going to be the same length for the quarter of a circle. It's like a pie. You're just taking 1/4 of a pie. That's the best we're going to get. All right, so let's say this is 4 inches. Okay, if this were a whole circle, then our circumference would be 2 times pi times 4, or 2 times 4 times pi. So that's the circumference. Now, if we are only going to analyze 1/4 of that circle, then it would be divided by 4, which would give us 2 pi. So this purple piece has a length of 2 pi. Here's what gets tricky. When you're talking about the perimeter of the whole figure, students always forget these 2 legs. And these 2 legs are going to be the same length. So it's 4 plus 4 plus 2 pi. So it would be 8 plus 2 pi. That would be your numerical value. And then we are working in inches, so that would be your units. If they want the approximation of that, all you would need to do is come over here to your calculator and do 8 plus 2. And I'm going to tell you guys on here, they are going to want you to substitute 3.14 in for this value. So 2 times 3.14. So it'd be approximately, because remember, when you're plugging in pi, or 3.14 for pi, it then becomes an approximation. So approximately 4.28 inches. Okay, so again, you're just taking the pieces and they do want the perimeter of the figure, and that's how you would find the perimeter. You would figure out the quarter piece of the circle, add in those other pieces, use your calculator if you want to substitute in for pi, and then you are good to go. Okay, let's do another composite figure. Again, this is more of a window shape. And I am actually going to draw a square. And I am going to draw a circle. And then I am curious if it will let me erase this piece. Nope, it will not. Good to know. All right. So we have a rectangle. And then we have the arch connecting that rectangle. And again, pretend that's a good circle. I feel like it could be so much better. It's okay, whatever. You guys get the point. All right, so when you're given a figure like this, they're going to give you a length here. So let's say this is 5 and this is 12. This length here corresponds to that diameter of your circle. Okay, so this is what they call a semicircle. It's half of a circle. And so the diameter right here is what it sits on. That's going to be 12. Okay, and they want to find the perimeter to the nearest tenth. Looks like on one of your questions. So we need to calculate this. This is actually pretty simple because remember we're calculating perimeter. So it would be 5 plus 5 plus 12 for all those pieces on that rectangle. This is where it gets a little interesting. Remember, circumference is equal to the diameter times pi, right? Well, our diameter on this one, if this is 12, then that had to be 12, which is your diameter, so it's 12 pi. But it's a semicircle. It's only half of that circumference. So we would need to take this and cut it in half, which would give us 6 pi. So this semicircle distance is 6 pi. So we would add 6 pi here. All right, and then you would just go over to your calculator and 5 plus 5 plus 12, because that's the bottom piece, plus 6, come on, mouse. So about 40.8. Okay, so it'd be about 40.8. A lot of students make the mistake of adding in that extra 12, but if they just want the perimeter, they really just want that distance around, which is the 3 pieces here and then up. And it is actually dashed. Dashed lines never count as your perimeter. So the final answer was 40.8. I forget which measurements we were using. We'll use centimeters. And again, we're working with perimeter, distance around something, so it's not squared. It's not an area. It's just the distance around. All right. Okay, one of the questions is asking specifically the distance or the perimeter of a semicircle. So again, a semicircle is half a circle, and it will give you the information that it has a radius. Let's do a radius of 10. Okay, a radius of 10. So if it has a radius of 10, the diameter would be 20, right? Because 2 radii is 20. So circumference is the diameter times pi. In this case, it would be 20 pi, right? But it's a semicircle, remember? So we got to take half of that. It's only half of it. So it would be the circumference of the semicircle would be 10 pi. So the perimeter of the semicircle would be the piece it sits on, which is 20, plus that distance of the circumference, that semicircle circumference.